So we've had a brief introduction to Microsoft PowerShell. Now it used to be called Windows PowerShell, but these days it's called Microsoft PowerShell because it's cross-platform. There was a time, such as when it was introduced back in around I think 2006, when PowerShell was designed to run only on Windows. These days it can run on the Mac OS and it can run in Linux. So it's very useful in an enterprise environment where you might be running those different platforms. We know that PowerShell is literally an executable program on a Windows machine at least, PowerShell.exe. But what's interesting is that PowerShell is an object-oriented scripting language. It's not for developers, although you can develop some pretty complex things. Really, PowerShell is designed for host and network administrators. Now, object-oriented means unlike older shells, like let's say a Linux bash shell, where the output is purely text, the output of something in PowerShell is an object. You might say, what does that mean? Let's say I want to get a list of hard disks in my machine. So in PowerShell, I can do that by issuing the get-physical-disk commandlet, which we're going to look at in a couple of seconds. Now, what if I have more than one disk? I've got 3 disks. Well, that means I have an object collection. 3 objects, 3 disks in this particular example. Each of those is an object. Oh, I get it. So each item of output is an object. That's correct. So that each of those objects has a collection of properties or descriptive attributes, like the type of drive, the interface, the amount of space that's free, the total capacity. Those are properties. Each object also has methods that you can run against it, an action, such as to reformat a disk partition on that physical drive. So that's what object-oriented programming is about, as we're going to see as we start issuing some commands. Now, just like with the Windows command prompt, depending on what you're doing, when you start PowerShell, you might need to start it with administrative privileges, depending on what you're going to be doing. So PowerShell scripts have a file extension of .ps1. Now, the interesting thing is it's just a text file that has that file extension. Just like in a regular old school Windows command prompt, the batch file has an extension of .bat. PowerShell is PS1, and within it, you can put all your PowerShell statements that you want to execute when you invoke that PowerShell script. Okay, so let's take a look then at some of the things that we can do in PowerShell. Really, what we need to do is launch PowerShell first. So here on my Windows computer, I'm going to go to the Start menu and type in PowerShell. Now, like usual in Windows 10, because that's what I'm running, we can just open it with our current credentials, or we can run it as an administrator. Now, if you're not signed in with an admin account, you might be prompted to sign in as an admin. Otherwise, you won't be. You're just going to be prompted to run it with elevated privileges, which I will do. Okay, so at this point, I've started PowerShell, as evidenced by the prefix here for my prompt. It's PS for PowerShell. When you spawn PowerShell directly from the Start menu like that too, you get a blue screen, so you know you're not in a regular Windows command prompt, which normally is just a black screen. Of course, you can change those colors, but those are the default settings. So the thing to bear in mind here is that PowerShell uses libraries of commands that you can issue. They're called modules, and you can get a list of the loaded modules in memory with get-module. Now, if you want to get a list of all the modules or all of the libraries of commands that you can issue that are available on the machine that are installed, you could run get-module-list. Now, you might wonder, that's great, but who cares? You might care because let's say you want to manage something that's not built into Windows like VMware. You're running on-premises VMware ESXi hosts, running virtual machines, and you want to manage that environment in PowerShell. You can do it. Maybe even write scripts and schedule them. You can do whatever you want. So in order to do that, I would need to have the VMware library or module installed on this machine. So that's why it can be important to run get-module, in this case -list, to see is it here? Because if it's not, and I'm trying to run VMware PowerShell commandlets, it's going to say, I don't know what you're talking about. Command not found. So that's an important part of this. So this is interesting because we're not limited to managing just aspects of Windows like disks or Active Directory. You can also manage the cloud. Now let's take a look at that. What we're going to do here is go into Microsoft Azure in the cloud, the Azure portal, the Web GUI tool, and you'll see why. We're here because At the top center of the screen, once you've signed into the Azure portal to the right, there's a little button that when I hover over it, it'll say Cloud Shell. I can click that. It opens up a new screen at the bottom. The first time you do this, I might ask you to create a storage account. That's fine. I've already done that. So what's happening is I'm actually spawning a PowerShell command line environment directly in the cloud. Now, why is that relevant? Well, we were just talking about PowerShell modules or libraries that give you more additional commands to manage other stuff outside of the norm in Windows. What about in the cloud? Well, what I can do here is, let's say I can run PowerShell commandlets that normally would not work on premises unless you've installed the Microsoft Azure PowerShell tools. Get-AZVM. I want to retrieve a list of Azure virtual machines. Let's press enter and see what happens. Is it really that easy? Of course it's that easy. So now we have a list of the virtual machines that result from issuing that commandlet. So that's pretty cool. There are some other ways that we can run PowerShell besides just running it on our own on-premises system. However, let's go back to PowerShell on the local machine. Okay, remember how we said PowerShell is object-oriented? Let's take a look. If I were to run, let's say, get command, and I'm wondering, are there any commands that have the word disk in them? So I'm going to run get-command asterisk or star, it's a wildcard, disk, wildcard. Show me anything that's got disk in the name. And there's quite a big list here. Wow, a lot of disk stuff I can do. Well, by looking at that output, I might then pare down that statement. It's like a discovery command and say, listen, let's get a list of PowerShell commandlets or commands that have physical disk in their name. Smaller list. So what I can see here, for instance, is I have a get-physical disk commandlet. Okay, so that's how I can find out what's available. Get-physical disk. I'm guessing that's going to show me all the disks I have in my machine, including things that are plugged in. Let's see. Oh yeah, I've got an SSD, it says. I've got a hard disk drive. They're both showing up here. Each of those is an object. Together, it's an object collection. Now, we can also do things like this. Get-service to list all of the services installed on this computer, whether they're running or not. So in this case, quite a lot of services. Some have a status of stopped, some have running. I only want to view the ones that are running. And this is where having an understanding of objects and all that stuff comes in. You'll see what I mean. How do I filter this list? Well, what you can do in PowerShell, let's go back to our first commandlet, get-service. What I can do is pipe the result of one command and pass it off to another one for further processing, like filtering. The way I pipe it is with a vertical pipe bar. You can shift your backslash key on most keyboards to get the vertical pipe. That means I want to pipe the result of the command on the left to the command on the right. So what am I going to pipe it to on the right? In PowerShell, there is a command alias called where. It's a filter. So where is in W-H-E-R-E. And what I can do is use a curly open brace and put my condition in here, my filter. Now this is where it gets weird, but it's only weird for a second until you know. I'm going to put in $_. Oh no, this feels geeky already. That is a built-in placeholder variable. Let's think about what's happening. Get-service returns all the services on my computer that are installed. That's a collection of objects. I need to process each object in that collection to see if it's running. So how do I, one by one, check each object? Using the placeholder variable, $_. It's that easy. So the next thing I do is put in a dot and the name of a property that I want to check. In this case, there is a property of each service called status. That's going to tell me if it's running or not. I put in an operator, so space-EQ for equals, and in quotes, running. And I'll close my curly brace. So what am I doing? Get a list of all the services, filter it where the status of the service is running. Let's see what we get. When we press enter, all we see now is a list of only the running services. In order to really work well with PowerShell, it takes a bit of experimentation and having an understanding that it's object-oriented and how to refer to things like properties, like the status property. In this case, we're checking to see if it's running. Now, there are a couple of other things that we should also know about PowerShell. And that is that when we have a lot of output, so for example, let's go back to get-physical disk, it returns a list of column headings and the details under them. But let's say I only want to see very specific things. So maybe what I want to see when I run git-physical disk is the name of the disk, the media type. The media type is either solid state or hard disk, and maybe the size. That's all I want to see are those properties, those attributes. So what I could do is I could run git-physical disk and I could pipe that to the select command alias. Select means I only want to select certain things in the output. Okay, so you have to know the names of the properties or the attributes, but I know what they're called. One is called friendly name, comma. The other is called media type. I want to see that, and then comma, size. When I press enter, I now have a very nice, neat list. All I'm seeing is the name of those disks, the media type, and the size of them, specifically in bytes. Now, the last thing I just want to point out here is that I can run git-execution policy here in PowerShell. And currently it returns unrestricted. Now, I could change that using set-execution policy, but you might be wondering, that's great, but why is it important? The execution policy, as you might guess, controls whether PowerShell scripts are allowed to execute on this machine. Now, from a security standpoint, a lot of malware will manifest itself as some kind of a script and run on your machine. That's why this kind of configuration exists. So unrestricted means any type of PowerShell script is allowed to run on this machine. Whether it's a local script, whether it's running remotely over a network, we could set that to a couple of other options to limit it, for example, that we don't want to allow any scripts to run at all for security reasons. So now that we've done this, we have a sense of how to use PowerShell maybe to automate repetitive tasks. And at the same time, we've seen how it's an object-oriented type of environment as opposed to the traditional Windows command line or Linux bash shell, which are completely text-based. They result in text output only. For the Security Plus exam, you need to be familiar with PowerShell. You don't need to be a hardcore expert. Now, there are many other courses and training resources if you do want to get well-versed in PowerShell. Don't worry about memorizing syntax, but understand the logic behind using PowerShell. It'll go a long way to giving you easy points on the Security Plus exam.